Hello, my name is Nathan Cabero, and I will be talking about the introduction and conclusions of the logic of psychiatry. With the introduction, we'll be talking about the logical basis of psychiatry, the questions we wish to answer, as well as the logic circuits and the disorders that we plan on covering. When approaching a diagnosis, psychiatrists often refer to the DSM-5 as a checklist for symptoms to arrive to a certain diagnosis. We use those statements given to us by the DSM-5 to answer certain questions, such as, is there logic to psychiatry? What patterns and structures become evident? And how can these logical structures be used to improve patient prognosis and diagnosis? With the logic circuits, we plan on using the logic gates of and or, which are human language, as opposed to computer language, NAND and NOR. We plan on covering the three main types of disorders in the DSM-5: anxiety, mood, and thought. And I'll be passing it off to Koshish.
My name is Kostas Resta and I'll be talking about the result portion of our project. For the first phase, I'll be going on the illustrative phase, and for the phase 2, I'll be going over the computational phase. For the first phase, I'll be talking about the proof of the concept, some examples, and then I'll be talking about some interesting approach. So the first phase is basically a bottom-up approach, and the phase 2 is what we call the top-down approach. At first, we translated all the DSM Axis 1 diagnostic criteria into a logical circuit with the help of Boolean algebra, and then we used multiple and OR gates. And an interesting example we took was from the generalized anxiety disorder. So for that, we took a multiple condition that is based on the DSM-5 module, and then used adder and comparator to do the threshold checking that is also based on the DSM-5. So one of the interesting observation that we observed in the circuit diagram was that the anxiety, it almost covered 50% of our logical circuit due to more symptoms, and the thought and mood disorder, it had lesser circuit diagrams. For phase 2, I'll be going over the universal logic engine, the number of pathway analysis, and the hoarding disorder. So at first, what we did is we basically created a computer program that can create a logic circuit for any given number of gates. So the most important thing from this computer program is that we are able to find the pathways and compute the number of pathway analysis. For hoarding disorder, what we did is we basically used 1 OR gates and 4 AND gates to display all the possible 10,800 circuits. And for that one, we got the number of pathways to be 3. So that is basically, we got the positive diagnosis for only 3 out of the 64 input combination that we have. And as you can see in the diagram, these are all the 3 pathways that we can compute for the hoarding disorder.
For the conclusions, I'll be talking about the implications for psychiatry, computer science, as well as our future work. For psychiatry, we will use our work to provide psychiatrists with more information in order to further refine diagnosis and align with treatment modalities, as well as improve the monitoring of diseases. For computer science, we take our number of pathways analysis and we come to the conclusion that the number of pathways that lead to a diagnosis using human logic, so and OR gates, is completely different than the number of pathways that lead to diagnosis using computer language, so NAND, NOR, and NOT. The implications of this can apply to large language models, which are largely based on human logic. For our future work, we will be working with the Department of Psychology to collect real-world data and compare that data with our pathways that we obtained.